Hello guys! In this video, we are going to discuss shear stress and solve sample problem in shear stress. So shear stress denotes with the small letter tau. Shearing stress is defined as a type of stress that acts coplanar with cross-section of material. Shear stress happens when a force tends to cause deformation of a material by slippage along a plane or planes parallel to the imposed stress. Shear stress is equal to shear force over area parallel to the shear force. In this figure, it shows a tensional stress which tends to lengthen the material, and then a compressional stress which tends to crush the material, and the shear stress which causes slippage to the material. Okay, so let's solve an example in shear stress. A rectangular piece of wood 50 millimeters by 100 millimeters in cross-section is used as a compression block shown in the figure. Determine the axial force P that can be safely applied to the block if the compressive stress in wood is limited to 20 megapascal and the shearing stress parallel to the grain is limited to 5 megapascal. The grain makes an angle of 20 degrees with the horizontal as shown. So the grains represent by this plane and the force P here. Okay? Recently, we already learned that stress is equal to force over area. So this time, we have two types of stress. The normal stress, which is compression, and a shear stress. So our normal stress represents delta, and our shear stress is represented by tau. So in shear stress, it is affected by the shear force and the area parallel to the force Fv. While normal stress, which is compression, so it is affected by the compression force Fn, or the normal force An perpendicular to the force Fn. So let's make free body diagram, so representing the plane and the force. So here is our free body diagram. This is the plane of the grain. So this represents the grain of the wood, so which is 20 degrees inclined. This force P is the force we are going to compute. Since our force P is not perpendicular to the plane, so it causes normal force N and a shear force Fv. So the normal force Fn tends to compress the block or tends to crush the block, while the force Fv tends to cause a shear on the grains of the block. To get the Fn and Fv, we need to calculate the angle of force P. So the angle from the normal line. To easily get the angle, we just rotate the plane 90 degrees. Now, we can easily determine that the angle between Fn, or the normal line or the normal force, and the line of P is 20 degrees. From that condition, we can already determine the value of the normal force N and the force V. The force V, since it's opposite to the angle, so we use P times sine of 20 degrees. And since our Fn is adjacent to the angle, we use cosine of 20 degrees. Okay, so Fn is equal to P cosine 20 degrees. Next is we need to consider the plane. We need to get is the area perpendicular to the force and the area parallel to the force, which is this one, the plane with the hatch. Since this is a rectangular surface, so we just need to multiply the length and the width. Okay, so to get the area parallel to the shear force, also the area perpendicular to the normal force. So this is equal to 50 millimeters times 100. So we just need to divide 100 to the cosine 20 because the length, this length is adjacent to the length of the block. Okay, so from that equation, we calculate the area, which is equal to 5,321 square millimeter. Then after that, we can already get the value of P. Since from shearing force equation, FV is equal to P sine 20. So we just need to replace FV with P sine 20 and then use the shearing force 5 megapascal. It is equal to 5 Newton per millimeter squared times the area, which is 5,321. Simplifying this equation, we get P equal to 77,781.87 Newton, or simply 77.79 kilonewton. Okay, the next thing to consider is the normal force, which tends to crush the compression block. So Fn is equal to the stress, compressive stress, this one, times the area perpendicular to the normal force. So area of the plane perpendicular to the normal force. So just substitute the value of Fn from our equation before, which is equal to P cosine 20, and then equate it to 20 megapascal or 20 Newton per millimeter squared. We use 20 megapascal because this is the allowable stress for compression. It means that our compression block is stronger in compression compared to shearing. So that's why it has a higher value of allowable compressive stress than the allowable shearing stress. So simplifying the equation, we get the value of P considering the compression, which is equal to 113.25 kilonewton. So now we need to decide what will be the maximum force. Of course, the smaller one, because when we load 113 kilonewton to the compression block, it will be damaged because the block can only carry 77.79 kilonewton in shearing. So it means that when the force P becomes greater than 77.79 kilonewton, our compression block will damage because the grains will slip. So that's all. Thank you guys for listening. I hope you learned something from this video.